Recorded now. Today we are looking at a new topic which I had covered a couple of times in past years, but did not cover the last 3 or 4 semesters for sure. This is turtle graphics, where you can use Python to draw stuff on the screen. So it is an interesting topic, but I didn't cover it in the past few semesters for different reasons. Anyway, we decided that we would like to bring this back into the curriculum. So another instructor and I decided that we wanted to do this again. So we are going to talk about that today. Even more importantly, in a more general sense, I want you to really understand that you can't start solving problems by immediately going to the computer and start typing in code. You have to think about problems. That is the larger learning outcome of this lecture, I hope. So we are going to look at problems that are more complicated than we have been seeing in the last 3 weeks, and attempt to solve them. So what I want to do today, how I want to proceed is this. I would show you a problem and ask you to think about it for about 10 minutes in groups. So I will split the class into breakout rooms. You can talk about the problem a little bit, what you find difficult, where you have some knowledge gaps, etc. I'm not asking you to solve the problem, okay? So don't get panicky. So don't start worrying how you're going to solve the problem. Try to understand the problem and what you find difficult about the problem and what you might find your gaps are with respect to knowledge. And then we will come back after 10 minutes. I don't want to spend more than 10 minutes in group work. And then we'll come back and I will show you my approach to solving the problem. Then we will take a similar problem and then I will explain that to you. And then you can start your class exercise. And part of the class exercise will be to work in groups on solving the problem that I pose to you, okay? And that will be also the lab. Implementation of that will be the lab. So I'm sure you're a little confused as to how things are going to flow today, but don't worry. I just wanted to give you an overview. I will give you more detailed directions at every stage. So don't worry about anything at this point. I just wanted to tell you that it's going to be, the flow of things would be slightly different from previous weeks. So there will be a lab, there will be a class exercise, and there will be some lecture component. Having said that, I also want to ask you to note that the first exam is next week, a week from today. It will start shortly after 9:10, after giving a few pieces of directions to you, and then it will be for 3 hours. So you have to submit your your exam by the deadline. There is a little document on D12 regarding the exam. So I encourage you to take a look at it. The exam will contain multiple choice questions, true false questions, multi-select questions, plus a few problems where you have to write Python programs. And the Python programs you will have to submit as a PY file, upload it to the Dropbox, and everything has to be turned in by the deadline. Okay, so I will have specific directions next week about submission and completion of the multiple choice questions and my view on those things. And in the meantime, I ask you to take a look at the exam handout and study for the exam. So are there any questions before we look at the problem that I wanted to solve in class? Any questions?
I am running into a logistical problem in that D2L is down from a Chrome browser. I don't know if anyone else is seeing this.
Huh. I'm not having any problems accessing it. Is anyone else having the problem? Can somebody else try out D2L?
It's fine, I think.
It works for me too.
Weird. I'll just keep playing around and see what's up. For some reason, it's not working on my laptop.
Try Firefox and see if that works. I know sometimes when I can't use one browser, I use another.
Yeah, and I tried Microsoft Edge, but I'll give Firefox a try.
Okay. All right. We still have a few minutes before you can. You need to access D2L, so hopefully it will be sorted out by then.
Yes, Professor.
Yes.
And the exam in the exam document, it says PM instead of AM. 9.
Did you try it now? A few minutes ago?
I'm talking about the time on the exam. It says 9.
I know. When did you download that?
Last night.
Yeah, I realized the mistakes. There were a few things, so please try it again. Please download that again.
Okay, thank you.
Yeah, I saw that mistake. Yeah, it should be okay now. Thank you. Anything else? Okay, let me share the screen with you, to talk about the problem. Let me tell you, don't panic, okay? The worst thing that you can do is to panic when you see a problem. You have to just think, okay? And here, I am going to solve the problem, not you. So don't worry about you're having to do it without any help. All I want you to do is to appreciate the fact that it is not an easy problem, that there may be some gaps in knowledge, etc., etc. And I want you to adopt a technique that will, in general, I'm saying, not, in general, I want you to adopt a technique that will actually help you recognize what gaps in knowledge you might have, how you would take care of those gaps, how you would approach the problem, do a systematic, have a systematic sequence of steps that will help you solve the problem rather than try all kinds of things and fail, okay? So let me share the screen with you, and then we will pray. Let me explain, then I will explain. Okay. So I hope you can see the screen. This is a document available under lectures. So the problem is to design and implement a Python program using turtle graphics. So I hope all of you have read the book, saw the video, etc. Okay, the problem is like this. Write a Python program that works as follows. It prompts for and reads the width of a box. Let's call this value width. So you're going to get just one number from the user, and that is, you could assume it is a float or an int. It really doesn't matter that much. So it is going to, let's call it width. It draws a box. By now you should know that turtle graphics allows you to draw lines. So if you draw 4 lines, you can get a box, right? It draws a box with a black outline. The width of the box is width. You read that here, right? And the height is width divided by 7. This box is centered on both axes. What does that mean? Well, if this is your window in Turtle Graphics, you know that there is an origin that is at 0, 0. So everything has to be centered around the origin. A rectangular box has 4 sides. So the width of the box should be centered horizontally. The height of the box should be centered vertically. That is what this is. Then it draws 7 circles inside this box. Each circle has a diameter of width divided by 7, and the circles have the colors of the rainbow. So these 7 circles fit perfectly into the rectangular box. That is the problem. So you should have access to this document, and I will keep this on. So I'm going to create, I'm not going to say much more about the problem. I think I have explained a little bit, but I don't want to do much more at this point. I want you to work in groups for 10 minutes, not more. And then I will then we will all come back to the main room, and then I will show you the solution. So let me go ahead and create the breakout rooms. I will be coming to each breakout room, but I won't be able to spend a whole lot of time because we only have 10 minutes for this activity. So please go to your breakout rooms and then see whether you understand the problem and talk about it a little bit. All right, let's talk about the problem. All right, so I hope you have a sense of what is to be achieved. And this problem obviously is far more difficult than anything you have seen up until now. much, much more difficult. There are a couple of things that you should do or not do. One is don't panic when you get a problem. Second thing is don't rush to the computer and then start typing in Python code. Those are the two things that are going to just make it impossible for you to solve anything, okay? So when you have a problem like this, there are certain reasons why it might be difficult for you to get a solution. One is that there may be some general knowledge that you are lacking. Then there may be some problem-related knowledge that you need to make sure you understand. And then there may be some Python stuff that you are not very sure of. Definitely, these are three areas that you need to worry about whenever you get a problem in computer science. General knowledge, in this case, it would be things like what are the colors of the rainbow? Or, I mean, it is not true of this class, but I mean, what do you mean by diameter? You know, I mean, those kinds of things. Or in the assignments that you're going to get next is what is percentage? That would be an important thing for assignment 4. Okay, so those kinds of things. So that is general knowledge. If you don't know something, you have to look up, you have to ask people, you have to understand that part. Second thing is making sure that you understand the problem. Okay, what is precisely asked. And the third thing is Python related knowledge, especially for today, it is the turtle graphics mechanisms. How do you draw a circle, for example? How do you fill a circle? Those kinds of things. So we will discuss all these three things now. So let's start about Python general knowledge. The general knowledge here is, of course, one big thing is the colors of the rainbow. They are like this. There is a little acronym for it: violet or purple, indigo, blue, green, yellow, orange, red. These are the 7 colors of the rainbow. So that is the first thing. I don't think there is anything else that is serious here. Problem related knowledge is what is being asked. So let me go ahead and clear this. Well, in Python turtle graphics, there is an origin, and that is at 0, 0. So when you create a window in turtle graphics, there is, although it doesn't really show up, there is supposed to be an origin that is at x equal to 0, y equal to 0. X goes like this, right? And y is like this. And you have a width. Let me call it W rather than width for the moment, so it is a little easier to write. So you are asked to draw a box that is W wide. It has to be centered. So this is W, the width. So half of it should be to the left. The other half should be to the right. And then the height should be W over 7. And that should also be centered, which means the whole thing is W over 7. Half of it is here, which would be W divided by 14. The other half is here, W divided by 14. And you have to have 7 circles. It would be very hard for me to draw this on the screen here, but there has to be 7 circles. I'm sorry, this is not working out all that well. All right. So there will be a center circle, here. It's not coming out all that well in my whiteboard, but doesn't matter much. Okay. So there will be a circle here, there will be a circle here, and this will be violet, indigo, blue, green, yellow, orange, and red. I know this is a mess, but I hope you understand the idea. I will probably redraw this in a minute. So 7 circles fitting into a rectangle that is W wide, W over 7 high, and centered. Okay, so what is it that we are, I mean, that we have covered, I think the problem statement, we have covered what we should know by way of colors for the rainbow. Then the big question is, what is it about turtle graphics that we don't know? Well, we know that there is a coordinate system centered at 0, 0. What else should we know? All right. Well, you have to know how to draw a line. You have to know how to go there, how to go to a place, and how to draw a line. So you should know that there is something called turtle dot go to. Given an X value and a Y value, you can go to that place. You can go from one place to the other, and turtle will draw a line as you move. But sometimes you don't want certain lines. Sometimes you want lines. Then there is turtle dot pen down so that you can draw the line. Turtle dot pen up will take the pen up, so you won't draw the line. So there are all kinds of things like that. But what is it about turtle graphics that is a little more difficult? Well, I think it is drawing circles. That is a little unclear. If you read the book or read the documentation, you might not fully understand what that is. When you draw a circle with a certain radius, this is at some location X, Y. The center is at X, Y, okay? This is your coordinate system, and the circle is somewhere here. There is an X value and a Y value here. How do you get this circle drawn? Well, you can go to any place, right? You can make the turtle go to any place and then say, draw a circle. But where does it get drawn? Where is the center? That is the tricky part. All right. Let's keep things a little simple here. Let's assume that we want the center at this point, X, Y. There is something called a direction for a turtle. This is going to be important, so please listen carefully. Direction, there is something called a direction. You can direct the turtle in any direction. It could be like this, it could be going like this, like this, like this, in any way you want, right? So something, you can write turtle dot set heading and put 0 here, then turtle will be traveling east. Its direction will be to the east. It's as if you turned eastways. You know, you are not moving, but you are just turning yourself to the east. It is like that. You are not traveling by this, you are just turning to the east side. If you put 90, you are going north. So that would be like this. 180 would be going west, like this. And 270 will be coming down, south. So these just set the direction. They don't make the turtle go anywhere. For that, you use something like turtle.forward or turtle.goto, etc. All right. So suppose I want my turtle to be centered at X, Y and have a radius of R. One way of doing it, there are many ways of achieving this. One way of doing it would be to make the turtle go here and set the direction east. I know this is going to be confusing, so let me go ahead and erase some stuff. Okay. Listen carefully. Let me go to a location here. I will tell you what that location is going to be in a minute. Some location here, which is going to be on the circumference of the circle, and set my direction to go to east. So it would be like saying turtle dot go to, and I have to have two values here, which I don't know yet. I will tell you what it is going to be in a minute. Then I will set turtle dot go to, sorry, turtle dot set heading, turtle dot set heading, zero. So that will set the direction to zero. Now you can write turtle dot circle and R. Assume that R has some value in it, like 100 or whatever. Then this turtle dot circle, I'm losing the mouse, okay. The turtle dot circle will draw a circle of radius R, and where is its center? That is the tricky part. That is what is not going to be clear when you read the book or when you read the documentation. So I'm going to explain that to you. Turtle's direction is eastwards, right? So imagine yourself traveling east. Maybe from Minneapolis, you're going to St. Paul. You're traveling east, right? Then the center will be to the left. So if you're traveling east and the center is on your left, you're going north, right? This is east. Imagine yourself turning that way, looking to the left. This is north. So the center will be R units to the left. So the y coordinate would be at y plus, or rather the y coordinate of this should be y minus R. If this is y minus R, if you add R more, you will reach y. This is your goal. Your goal is to have the y coordinate here be this value y, whatever that is, like 500. And if your radius is 100, this has to be at 400. The x coordinate would be exactly the same here. So you should go to x comma y minus R and draw a circle with heading 0. You will get this circle here. That is the hardest part of doing this problem, figuring out where the center of the circle is going to be. Do you have any questions on this? All right, hearing no questions, let me go ahead and talk a little more about the problem, because there is still some stuff that we haven't covered. Well, where are these centers going to be? There are, this is not working out all that well. So let me go ahead and clear all this. There are 7 circles. The next thing is figuring out where the centers are going to be. There are 7 circles, right? 3, 5, 6, 7, and they are all in a box. This is green, red, blue, green, red, violet, indigo, blue, green. So this is green. And its center has to be at the center of the turtle window. So this is at 0, 0. Then what is the center of this? It would be at the same vertical height. So the x coordinate would be the same. They are all horizontal, I mean, they are all placed vertically in the same way. So this, the vertical offset of this would be at 0. But where is the x coordinate? It would be diameter units to the left. So the diameter is W over 7 for each circle. So this has to be minus W over 7. This will be, the center of this one would be another minus W over 7. So it will be minus 2W over 7, comma 0. And this will be at minus 3W divided by 7, comma 0. This would be at W 7, comma 0. This would be at 2W7, comma 0. 2W divided by 7, comma 0. This would be at 3W divided by 7, comma 0. So once you know the centers of all these, you are in pretty good shape. So you should know that this is at minus W divided by 2, the x. The whole thing is W. So this has to be at x offset of minus W over 2. The y offset would be minus W over 14. This would be at W over 2 minus W divided by 14. This would be at W divided by 2, W divided by 14. And this would be at minus W divided by 2, W over 14. So we can get the 4 coordinates of the box as well. So our plan would be to go to this point, draw a line, then draw a line here this way, draw a line for the top part of the rectangle, and complete the box by going down. So when you start, the turtle is here. When you start the turtle window program, the turtle is here, and you have to go all the way here, and you don't want that travel to be registered, so you have to put the pen up. So the first thing to do is to take the pen up. Maybe you want to also hide the turtle. Go here to minus W divided by 2, minus W divided by 14. Draw this line by going to W divided by 2 minus W divided by 14. Then go to this place, then go here, and go here. You would have drawn the box. Now you should have the code to draw one circle. So you need to go here, as I explained, for drawing a circle, and draw this circle of radius W divided by 14. That is the radius. The diameter is W divided by 7. This is the diameter. And once you draw one circle, you can copy and paste that six times. So to get the other 6 circles and adjust the place where you start drawing the circle and change the color. So the trick is to draw the box and draw one circle correctly. If you can draw one circle, you can just copy and paste that code 6 more times to get the other 6 circles. Any questions before we take a look at the code? Anything at all? So let me go ahead and see if I can show. Yeah, let me go ahead and show you the code now. Okay, here is the code. Let me briefly explain this. Here, I am asking for the side of the window, and then I am lifting the pen up, then hiding the turtle. I'm going to the leftmost corner of the box, put the pen down, set the color to black, go to each of the other vertices one after the other in the correct sequence, that will draw the box. So this code draws the box. Then each circle has its own code. Like this is the code for drawing the first or the leftmost circle, which is going to be in violet. I will explain this. After drawing the box, you lift the pen up so that you can go to the circumference of the circle without showing how you got there. So you go to the same x coordinate as the center of the circle and you go to the edge of the box. That is window width divided by 14. As I explained a little while ago, you set the heading to 0 so that you're traveling east. Set the color to violet. This would change all colors to violet. That is, if you draw a line, it will be in violet. If you fill something, that will be in violet. Put the pen down so that things start showing. I create a circle of this radius, window width divided by 14. That is the W that we used in the calculations a while ago. To fill this, I write begin fill before drawing the circle and end fill after drawing the circle. So whatever I draw between these two, begin fill and end fill, will be filled with the color violet. Once you get this, this is exactly what I did. I got my violet circle working. After that, I copied and pasted that. And then I said, okay, only the x direction, the x coordinate is going to change. So I'm going to go to window width times 2/7, negative of that, and change the color to indigo. Then then I executed the program. Then I saw that the indigo was working well. Then I copied and pasted to get all these other circles. Of course, I had a little issue here and there, but they were all sorted out very quickly. But if I had tried to if I had tried to solve the problem by starting to type in things without any planning, this would have been a disaster. I would still be programming. Okay. Any questions before we break out? Anybody? Okay. The problem, the lab is going to be, let me go ahead and show you what the lab is going to be. So what you need to do for the rest of this class meeting, there is a class exercise and a lab. The lab is going to be a little simpler than this, and it is going to be somewhat similar too. You are going to accept the width and height of a box. You don't have to draw an outline or anything. You have to draw 5 boxes. Drawing a box is a lot easier than drawing a circle, let me tell you. So you have to draw 5 boxes. They should be in this order: red, yellow, green, blue, orange, and green, in this order. This is the width of the big box. That is one of the things you'll be reading in from the user. Then the height is also something you read in. So the height of every box is whatever you read in. The width would be 1/5 because it is equally divided, 1/5 of the total width. The width of each box is 1/5 of the total width. So what you need to do is follow these steps. You need to write pseudocode that you will be doing in groups. So you are not creating the pseudocode in isolation. So you do your class exercise. There are 10 questions, I think, initially covering turtle graphics, multiple choice kind of questions. So finish those, then read these 3 steps. There are 3 steps here. Read them, then start following them. Don't start writing Python code until you have completed the class exercise. So write the pseudocode after you have read these directions. Read all these 3 steps before you start doing anything else. Okay, so there are, you need to write Python pseudocode before you write Python code. Otherwise you will be lost completely. And don't write things like import the total graphics library or the very minute details of drawing lines or anything of that kind. It has to be sufficiently detailed for you to understand to know how to solve the problem by writing Python code, but it shouldn't be too detailed either. So for example, here, let me show you what I have written for the I will post this I'll post this in a minute after I have set up the breakout rooms. Okay. Okay, let's, I hope you can all see this. I have opened a document that shows what I wrote for pseudocode. Well, I could have written my pseudocode like this: draw the big box, draw each circle. That is too high a level. This is not having enough details. Too vague, too unclear. How do I go about doing these things? That's not very clear at all. But here is a much more friendly version of the pseudocode. To draw the big box, you have to find out where the coordinates are, put the pen up and go to the first coordinate, put the pen down, go to each coordinate in the order, in the right order. So that is enough for somebody who knows total graphics, how to go about drawing the box. Drawing the circles would be achieved through this pseudocode. Enough to show how to draw one circle. How do I draw the violet circle? Radius. So lift the pen up, go to this place, put the pen down,